We are surrounded by motion. From falling apples to orbiting planets, the universe is a symphony of movement. But what dictates these movements? What are the rules of this cosmic dance? The answers lie in the elegant laws of motion formulated by Sir Isaac Newton. These laws, three in number, are the bedrock of classical mechanics. They explain why things move the way they do. Newton's laws are not just abstract theories, they are principles we experience every single day. Every time you walk, drive a car, or even just stand still, you are witnessing Newton's laws in action. These laws are fundamental to our understanding of the physical world. They are the foundation upon which we have built much of our modern technology. In this essay, we will embark on a journey to understand these laws. We will delve into the concepts of inertia, force, mass, and acceleration. Through relatable examples, we will demystify these fundamental principles that govern the motion of objects in our universe. Join me then as we explore the elegance and power of Newton's laws of motion. Imagine a ball lying still on the grass. It will remain there indefinitely unless something pushes or pulls it. This simple observation forms the basis of Newton's first law of motion. This law states that an object at rest will stay at rest, and an object in motion will stay in motion at the same speed and in the same direction unless acted upon by an unbalanced force. This tendency of an object to resist changes in its state of motion is called inertia. Inertia is the reason why you feel a jolt when a car suddenly accelerates or brakes. Your body, at rest or in motion, wants to stay that way. The car changes its motion, but your body, due to inertia, resists this change. Think about astronauts floating in space. They can drift in a straight line forever unless they use rockets to push or pull themselves. There is no air resistance in space, no friction to slow them down. This is Newton's first law in its purest form. Understanding inertia is crucial for understanding how objects behave in the universe. It explains why we wear seat belts in cars, why we brace ourselves when a bus makes a sudden stop, and why it's harder to move a heavier object than a lighter one. Newton's first law tells us that an object needs an unbalanced force to change its motion. But how does this change occur? Newton's second law provides a precise mathematical relationship between force, mass, and acceleration. It states that the acceleration of an object is directly proportional to the force applied to it and inversely proportional to its mass. In simpler terms, pushing an object harder makes it accelerate faster. Similarly, for the same force, a heavier object will accelerate less than a lighter object. This relationship is neatly summarized in the famous equation F equals sine ma, where F is force, m is mass, and a is acceleration. Imagine pushing a shopping cart. The harder you push, force, the faster the cart speeds up, acceleration. Now imagine pushing two shopping carts stacked together. You need to push much harder to achieve the same acceleration because you are now pushing a larger mass. This law is at play everywhere. It explains why a powerful engine can accelerate a car quickly, why a strong wind can topple a tree, and why a small meteorite can cause significant damage upon impact. Newton's third law is perhaps the most commonly quoted and often misunderstood of the three laws. It states that for every action, there is an equal and opposite reaction. This does not mean that every force is cancelled out, but rather that forces always come in pairs. When you jump on a trampoline, you exert a downward force on the trampoline, action. Simultaneously, the trampoline exerts an equal and upward force on you, reaction. This upward force propels you into the air. Similarly, when a rocket blasts off into space, the rocket expels hot gases downward, action. In response, the gases push back on the rocket with an equal and opposite force, reaction, propelling the rocket upward. Understanding Newton's third law is essential for comprehending a wide range of phenomena, from the flight of birds to the recoil of a gun. It highlights the interconnected nature of forces, reminding us that every interaction involves a push or a pull from both participating objects. Please like, share, and subscribe for more insightful content.